So we're almost at the halfway point of the year, which is the June meeting. Um, I must admit the last month's been quite interesting in terms of things as well. We will talk about that afterwards, but also with the since really the Artemis 2 mission, there's been quite a few things happening with NASA. And tonight I'm going to give you a bit of an update on some of the major policy announcements that they have made. That you have to put it in context. The NASA really, with the new presidency, didn't have anybody as the administrator really for 12 months. There was several NASA bureaucrats acting in the position, but not a presidentially appointed person, which means that they're not necessarily following president's ideas on space policy as well. So it does leave a bit of a what you call a policy vacuum at NASA's level. And usually with every administrator, they'll work out what they want to do over a period of time. So the new administrator came in this time, Jared Isaacman, who was appointed late last year, and what we're actually getting is something quite significant in terms of a policy announcements about 2 to 3 months into his start of the term. So what NASA did was hold an event at the end of March, which was just about a week before the Artemis 2 launch, talking about what they called Ignition, which is the media event that they did. It was a couple of hours event where they gave an overview of what they were looking at doing. In this case, really over a 10-year period. It wasn't just this president's term, but their vision goes that far out. So there's quite a few things covered in this talk, and and there was another event late last month, just on the lunar base itself. It was a media event, which was just going into a bit more detail on the lunar base itself, but also some of the announcements with who had won contracts to deal with that, building the base. So there's some initial things in phase one, which obviously require partners to be announced almost immediately to get that in place, and that was the reason why they had those announcements coming almost, just after the other events, so that those particular contractors can start building what they need for the lunar base that they need to set up. Okay, so at this particular event called Ignition, they had Jared Isaacman and I think about 4 other senior executives at NASA talking about some of the key programs as well as the new policy. And I'm going to cover most of those tonight, some in more details than other, obviously, and we'll talk about why. But it was a very large tranche of things covered. First thing was the alignment with the current national space policy, a change in lunar exploration strategy, commercial and international collaboration, workforce development and policy, and implementation and oversight. Those are the main things that the policy changes involved. And what I intend to do is to cover some of the, I suppose you could say, some of the simpler and smaller ones first, and then we'll go at the end of the presentation, we'll mainly be focusing on Artemis and the lunar base. So to give you a bit of an insight on how so the order I'm covering these is probably slightly different to these main points here, but you'll see why in a minute. Okay, so we're going to start in low Earth orbit, and that makes sense, with the ISS. Now, this is an overview of what the ISS has achieved in the 20 years. There's quite a lot of things you can see with the number of shuttle flights and 160 spacewalks. In the order of, I think it's taken 50 billion just to develop and assemble, and 100 billion to date, which I think is really an expenses towards it, and all the amount of research it's been doing, and the number of researchers involved, which is 5,000 plus, and 110 countries involved, one of which is Australia, and it's had over 290 visitors. I believe that would have been the numbers that they came up with in March. And that's probably a little bit higher than that, obviously, but that's where the station's going in terms of how well it's fulfilled its duties. But one of the big problems of the space station is the age of some of the components. I mean, if you weren't aware, there's actually been some things happening in the last couple of weeks, even with the station crew that's up there. There was issues with the Russian component at Zarya in terms of a leak, and it's a slow leak, but it is concerning them because obviously, from an engineering perspective, some parts of that station are over 30 years old, and sometimes that's beyond the way it's rated, and it's becoming potential risk. So the NASA had thought about deorbiting the station, but it's not trivial with all the investment they've got in that, as you can see. So what they were looking at doing, and this is what NASA had stated, that there was no compelling products made, and these are facts of life with what's really happened, how they see things now, which we'll talk about in a few minutes what that means, but no compelling products made in orbit. There isn't any substantial tourism demand. No other governments wanted to pay for long-duration orbital access to a US-based space station. So reality of it is that there's a limited market for it, what the station's currently doing. But they have things NASA wants to keep obviously doing science in space, but they're now in a situation is that the 2030 date is potentially a problem with any potential replacements, right? So they're now thinking about at least 2032 trying to extend the station. But of course, if anything goes wrong in the interim, the station might be abandoned. So we'll see where that goes. But that's how it's going at the moment. So they've admitted they need to give it some additional funds for a couple of years. And the original plan, as NASA sees it, is to try to one thing to note with the existing station is there is a lot of hardware that NASA has brought up in those research racks that were installed in the initial 5 years of the station's life. They were very expensive to get together and to build, and it would be a shame to waste them. So the idea about anything that NASA proposes for a replacement is to try to reuse a lot of what is currently on the station anyway, with any new replacement for it. So everything that NASA is thinking about is gearing around trying to build temporarily attached modules to the existing space station and to try to get them commissioned properly and tested, and then to move the components into it and, later on ideally separate it. So you can see by these slides here that, you might start with the core module, and looking at the example that we got here is Axiom Spaces space station that they were proposing. Now, we'll talk about the different players at the moment, but one of the problems with this side is that the partner, Axiom Space as a partner, is involved with the Artemis already, but they are having funding issues with getting the station built. So, when this is all going to happen is a problem. They're building some of the modules at the moment, but you have to think about how quickly things are going to happen in terms of when are we going to potentially move the equipment that's on the ISS into another space station if you were going to do that. So you can see that the different stages we're looking at. NASA's thought on how that would be done would be put a core module up and then put some commercial modules attached to it, and then move components into those other modules. And if it was attached to the ISS, it would be separated from the ISS, and then it would go its own way. But they would then have a lot of their own equipment already in the new station, and they would be able to work in that station. Okay? But of course, that's making certain assumptions about how this is all going to work out in terms of space stations. And of course, it's not as simple as that. partly for financial reasons. So I'll talk a little bit more about what's going on with other stations. When NASA gave this information to some of the vendors and potential vendors involved, there was a bit of a pushback on it. They were not very happy about how this was approached. So watch this space. It's not fixed. There may be some further changes to this, but I need to make a comment about how many players we've got involved here. There is about 4 different players in terms of commercial space stations at the moment. The original player that NASA was dealing with was Axiom Space. In fact, they've already had some crews going up to the ISS at the moment, and they have been paying NASA to do that. They have a module that they have intended to be delivered to the ISS for testing purposes in 2028. So it's still not ready yet. And I understood that some of the problems that they have had has been getting funding for building this station. So that's one of the drawbacks we've got with this. There was also another 3 players involved. The Blue Origin Sierra Space have got an orbital reef space station. That would be a New Glenn launch. That is quite a big space station. It's certainly a larger diameter than Axiom Space's space station modules, because Axiom Space's modules were a similar size to the ISS, but Blue Origin's orbital reef was probably about 50% larger diameter, obviously bigger volume for that reason. And it also means that you have to launch on a bigger, a launch vehicle that's got a bigger diameter. VAST, which has got Haven 1 and Haven 2. Now, Haven 1 is almost ready to launch. Apparently, they're testing that at the moment. It might even be launched as early as middle of next year, and it will be launched on a Falcon 9. So if it goes up, then they will actually put a crew there to test out that it's working and things like that. And you can see I've got a picture of those 3 of those players. It was Starlab and VAST. I don't think although Blue Origin was at the IAC last year, they actually had their own stands there. And Voyager Space is a bit similar in terms of the Vast and Orbital Reef. It's quite a large station in terms of diameter. So those particular bigger stations can only really be launched either Starship or New Glenn, not Falcon 9. So you can see the complications this is all creating at the moment with what NASA's going to do. How NASA wants to get their equipment into another space station is still up for grabs at the moment. We're not sure how that's going to work. So, but the winner is likely to be the space station that retains NASA as an anchor tenant and the one that demonstrates reliable revenue, and that's the truth of the matter. It's got to be a commercial station, and that's what we need. So we'll see where all this all pans out, but that's where we're really up to with the ISS. But it looks like that certainly it will be around till at least 2032 because they need to keep it operational, because they don't really have and NASA doesn't really want to have a period where it's no longer participating with, science in orbit. It wants to keep those racks intact and not lose them. So it's going to find a way of being able to transfer a lot of its materials into another space station, one way or another. So that's the key thing to take away from what NASA has announced. They've kind of realised and admitted that they have to do more work on this. So we'll hear more over the next 6 years as to what's going to happen, and that's where we're up to with that. So that's the first major announcement. The second thing which I found interesting was that we were looking at the future science missions that NASA was talking about, and there's a few good ones coming up and some that you may not even be aware of that are very visionary. We'll talk about those. I think I've got 4 in total we're going to talk about now. The Nancy Grace Roman Space Telescope is definitely now up for launch this year. In fact, it's under budget and it's also ahead of schedule. Now, originally it was going to be launched in September, but I believe it's now moved to August. So you can look forward to that. it's going to be soon, and that's great news. So that's an example where you can get a project that's properly managed and you can actually keep it to budget. So that's good news. The next one that of interest is the Habitable Worlds Observatory. I understand that's going up next year sometime. I really don't have a lot of information on that. I would think that we'll get some better diagrams. That's just obviously a schematic. It's not a real hardware photograph like the picture of Nancy Grace Roman, which is different, of course. But it will be going up sometime late next year. I believe that Goddard is building that because it's their image, so it's something that they've been working on. I don't really have any other further information as to what the launch vehicle is going to be. It's probably going to be a Falcon 9 or Falcon Heavy. I don't think there's a lot of Atlas launches left, so it's probably going to be that launch vehicle that goes up. This one was really intriguing, though. I found out it's obviously in fairly early day, but it's called Dragonfly, and it's going to be like a orthocopter to Titan. Yes, Titan, the moon Titan. It's going to fly around the Titan's atmosphere, and that's a picture of what it looks like. Obviously, it's got to do some. When it's going to launch, probably. Oh, look, I think that's up for launch in the next 4 to 5 years, but it's something that they had agreed to do now, and it's then going to be a matter of looking at the physics of doing a launch to Titan, obviously, to get it out that far, and you've got to then look at the planet alignments and things like that. So I would tend to think that this is not going to launch for 3 or 4 years, but the fact that NASA is now allocating funds for it looks really fascinating in terms of getting out to Saturn. So that's something to be aware of. There's also an ESA rover, the EXO rover, that's going up to Mars in 2028. That's called the Rosalind Franklin. NASA is actually not the major manager of that, but they've got some experiments on it. They might also be responsible for the launch, or at least getting a US launch vehicle. I think it might be a Falcon Heavy launch. So it's going to be a rover that the ESA is sending up to Mars to look for signs of life. I think that this particular rover has been delayed at least once. And obviously, if you look at the orbital mechanics for Mars, it's going to be like, it's going up in 2028, and it was probably going to go up this year originally, but the funds didn't work out and they haven't got it ready, and so it was being delayed, but it's going to be launching in 2028 to get there, and NASA's involved with that. The most intriguing one, though, is the Pathfinder mission that I believe, in particular, the Jared Isaacman was interested in doing, which is looking at nuclear power on a space probe to Mars. Now, I've got a bit more detail on this, we'll go in with it, but there's reasons why they wanted to do some prototypes of nuclear reactors, and it's going to be called SR1 Freedom, that's what they want to call it, and nuclear electric propulsion it's going to be using. So the nuclear power is going to be generating electricity so that it's going to be able to do electric propulsion of some gas. I have no idea exactly what that's doing it, but this is quite an aggressive timetable, obviously, 2028 for December launch, earliest opportunity, but the US Department of Energy would be involved with NASA on this because they have to build like a prototype nuclear reactor. Part of the reasoning behind why they want to do this is also relating to the technology being reused for the lunar base. So we'll talk about that in a minute. But the fascinating thing about it is that it was going to have a payload of 3 helicopters called Skyfall. And it was going to be something that they will actually separate from the lander that's coming down and do science in the Martian atmosphere. So the helicopters that they'll be building will be something like the Ingenuity that was very successful over there, and they'll actually be testing those out as well. And they're going to be looking for, obviously, locations for water ice. So it's going to have some instruments on it so they can look for things, and they'll have some cameras there as well. So it's obviously exactly how the Congress funding and support is still unclear. Yeah, that's right. I looked at that side of it, and it wasn't quite clear exactly how that's going to be funded yet. It's a new project, so we'll have to see how that goes. But certainly the administrator's keen on it, and there's reasons why you might want to do it. This is what it would look like. So it's a 48 kilowatt advanced electric propulsion system at the end of it, and it's got a power conversion system, and it's got a 20 kilowatt the reactor. So I'll see. That's the national concept at the moment. We don't know exactly what it's going to look like finally, but this is what somebody has come up with as a prototype for it. And why nuclear? Well, the advantage to also note with nuclear, we have 2 rovers on the Martian surface at the moment, which are currently nuclear powered. They're not solar. And we had one problem with Mars is that there is the dust storms do create a lot of issues with solar panels, and that the Spirit and Opportunity rovers that were on Mars a long time, they were suffering from problems due to the fact that the solar panels on them were degrading over a period of time. So the current 2 large rovers that are on the surface don't have that problem, but of course, yes, you can see in the case of nuclear is that it doesn't really matter in terms of how far out from the sun it's going. So it's just a matter of getting something operational. Because the energy density is very good, it's going to allow them to put something fairly powerful in terms of, and also this technology really hasn't been trialled a lot. So it's going to be really, as I said, a prototype for something for deep space exploration that people have thought about for a long time, but never really done. So it's going to be worth just developing something like this for future missions anywhere, really. Now, the timelines, as you can see here, was what NASA was looking at, was actually having this developed by 2028. But there would also be a lunar variant about a couple of years later. So whoever's involved with building this stuff, and that's the thing, obviously there's going to be a government department involved with it, but there's got to be tenders for doing the build. So some of this will become a bit more clear with the lunar base, but the intention would be to get the reactor built for Freedom, this space probe, and then use a large amount of the technology on the lunar reactor later on, a couple of years later when that was built. So that's really part of the reason for doing this project. The feeling is that the technology will be like a win-win for NASA for its future goals for other things happening. Okay, so now we're going to talk about the changes to Artemis. Of course, a lot of people were thinking that we were going to be landing on the moon with Artemis 3, and that has significantly changed in the last couple of months. Obviously, though, because of the fact that there was a few problems still with the 2 landers, and also as a demonstration mission after something that just was very much like Apollo 8. The problem with Artemis 3 is that it would have been doing so many new things that there was a lot of risks involved with doing it. So what they decided to do was to make Artemis 3 like a demonstration mission in low Earth orbit, very similar to, I suppose you could say, what Apollo 9 did, where Apollo 8 went around the moon, and then Apollo 9 went back in Earth's orbit to do a lot of testing on the landers, or one lander, in this case the lunar module. The plan will be similar type of thing. I suppose the debate will be is exactly how far these landers are going to be at the time when the mission is going to be ready. NASA is wanting to run the mission in probably August to October next year. That's what their time frame to try to run the mission is. In other words, summer in the US, that period. I don't know whether that will time frame work out, but that's what they're planning on doing. Okay, so we can talk about this a little bit further at the end here. It's a bit of a moving feast to know exactly how that's going to work out, but the crew was announced last week as well. Okay, so that now shifts Artemis 4 to be the first landing mission. We still don't know what the lander will be at this stage. I mean, the administrators basically says whichever of the two contractors is ready first, and that's what they'll select. Okay, so it might be SpaceX, then again it might also be Blue Origin, it depends. Okay, so, but the target date has been 2028 for a little while. For the landing, but now it's been moved obviously to Artemis 4 instead of Artemis 3. And what they would then be doing with Artemis 5 is a repeat of this, the landing, maybe with a different lander. It's not clear at this stage what they're doing, about 6 months after. And that's within the 2028 timeframe. Of course, we don't know whether those dates will be adhered to, but that's what their plans are. Just going through the HLS. This is based on Starship version 3, adapted for. You can see Starship is quite a big vehicle. It's 50 metres tall. Holds 2 to 4 crew. And can at least carry 20 tonnes. That's what the plan is. It's possibly even bigger than Blue Origin's lander in terms of payload capacity. I have seen some variations that indicate maybe it necessarily landing vertically, but we're yet to really see what they're doing with that. It's the jury's still out. This one is a little bit further down in terms of what the bid will look, the Blue Moon. This is a consortium bid in that there is different companies involved with some of the components. The lander you're seeing there is Blue Moon Mark II. Mark 1 is really used more for unmanned payloads. So this is a bigger lander than certainly the Mark 1, and you'll see the scale in a minute of everything, so you can see. But it's 16 metres in height. It's not as big as the Starship, obviously. And the manned version is planned to have a 20 tonnes payload. That's one of the NASA criteria for doing the lander, and that the 20 tonnes payload is something they were trying to aim for. However, it was really intended to be operational by 2030, but not 2028. So that might create some interesting things that we could talk about later as to why I'm saying that and what might happen that might be slightly different to what the original bid was. And you can see the sizes of them compared here. Obviously, both of them are larger than the Orion spacecraft. SpaceX being quite a lot larger, but even Blue Moon's 2 to 3 times bigger than it. It's quite a big lander, too. Just going back to the incremental capability development, trying to compare the different missions. So you can see there that they wanted to say that Artemis 2 very much was doing the same function that Apollo 7 and Apollo 8 was, like shakedown missions, also around the moon. That makes sense. And Artemis 3 doing something like Apollo 9 and 10. Yeah, but maybe not quite so much. But that's how NASA was paralleling Apollo. And obviously Apollo 11 was lunar surface operations, which is what we're looking at Artemis 4 and 5. Now, that's just the basic overview, but there is going to be some changes to future developments with Artemis, which I'll get into in a second. Looking at the national plan, though, this is more the NASA's own take on these. What they're intending to do, though, they were looking at doing testing of EVA hardware. That's the plan for Artemis 3. They would be either doing that or next mission like Artemis 3 or ISS. But they have to test the spacesuits out that they're going to use on the moon prior to going there. But the main thing that Artemis 3 will be doing is rendezvous testing for the two landing systems. Okay, so this is the crewed landing overview here. 4-person crew, as with this one, but there's only 2 of them going down to the surface. Still looking at Block 1, crewed. As it said, HLS is it's going to be either the Starship or Blue Moon, we don't know. Axiom Space is making the EMU for the landing. It's going to be South Pole. 2 to 4 EVAs, or 1 to 2. I think that really 4 is what they probably would be doing. But it was going to be around about 3 weeks. The mission was going to be in total, and they were going to spend about a week on the moon. So which is, I believe, twice as long as what Apollo 17 spent on the moon. So in that period, 4 EVAs makes sense. I think that would be, I don't quite understand where the 1 to 2 comes from there. But because I know that thinking about how it all worked, it doesn't make any sense as doing 2 EVAs. I think more likely they'll be doing 4. So, but with the 4-person crew, not everybody gets to go to the surface. That's an example looking at the suits from Axiom Space here. Of course, they're doing testing of the suits at the moment, but they won't be delivered until mid-next year at the earliest. So we'll have to see where this is all going in terms of whether they'll be ready to go up on Artemis 3, and we're hoping it should be available to go up. Certainly the astronauts that they've picked on the Artemis 3 crew have got EVA experience. There's a couple of them with in fact, 3 out of the 4 of them have got current EVA experience. I think one of them's even done about 10. So he spent a bit of time doing it. So I think that it's certainly possible that they could be testing it on that mission, but we'll see whether the suits are ready then. I don't think there's anything too exciting about this. Yes, we just don't know what the lander's going to be. Yep, that's right. The other major changes that were happening, though, about Artemis 4 was that there's some changes to the hardware involved. The interim cryogenic propulsion stage, which they used on the first 2 missions, and they still have 1 left of that for the 3rd mission. It was going to be originally replaced by a larger stage in what they call Block 1B. Now, Block 1B has essentially been cancelled. That would have also used a larger mobile launcher. And I think that what happened was that Jared Isaacman looked at some of the deliverables for those 2 things and realised that they were never going to happen quickly. They were running well over schedule, and unfortunately it really required cancellation rather than just hoping that it was going to be ready. So what they're thinking about doing, and I believe they have already issued contracts for two Centaur 5 stages that will be slightly modified, but they're used on the Vulcan launcher at the moment. They're going to be using those for, certainly would be Artemis 5, 4 and 5, I think. 3 might still use the ICP. But to be frank, the ICPS is actually derived from the Centaur 5 anyway, so it's a variant of it, but it's not. Centaur 5 is actually a little bit more capable. So it was probably like an earlier stage version of it, so because it was developed 5 or 6 years ago, whereas the Centaur 5 is more recent than that. So the hilarious thing about it is that it's not going to be that different what they actually put on the SLS to actually use it. There's going to have to be some minor changes apparently because the instrumentation's not identical, but I don't believe it's a big change. So that's what they're planning on doing. So the EUS and the Mobile Launcher 2. Now, Mobile Launcher 2 was something that was being built, and it got probably 3/4 through the build, but they were starting to have problems with it. So they were trying to commission it, and they were finding technical issues. So it wasn't clear when it was actually going to be delivered. So that's where that goes. So realistically, the reason why Block 1B was cancelled was that it became obvious to Jared Isaacman when he looked at the timeframes for it that nobody quite knew when Artemis 3 would happen if they were going to be dependent on Block 1B. Also, because they had issues with the mobile launch tower recently with hydrogen leaks, they needed to try to get that under control in terms of how that's being managed. So they're spending more time on trying to sort that out now. So they don't really want to have to recommission a brand new tower and have their own problems with a new tower. So they basically decided, no, we won't do that. We'll just live with the fact that we aren't going to get quite the same payload and manage it a different way. So that's an unfortunate fact of life. The Lunar Exploration Gateway project, which was really going to be like a space station around the moon, that's effectively been deferred indefinitely. I don't think they've used the words cancelled, but because they're thinking about repurposing the hardware, some of that hardware was going to be used on the SR1 project for Freedom, I believe. They were going to reuse the ion propulsion system there of the nuclear reactor. So I think that is, so I don't quite understand what's happening with some of the partners. There was some different partners there that were, I think UAE was involved with doing some work with NASA for Gateway project. I don't know whether they've been scoped in to work on lunar stuff instead, but there was also some people involved with that. So it's a little bit sad with that. And also I believe Canada was involved with the Canadarm. So that being shelved means that it won't be built. It won't happen. And we're now looking at the first 5 Artemis missions, which we have hardware for. There'll be launches for at this stage, but we're not quite sure what's going to launch anything after Artemis 5. NASA said that they could acquire an SLS vehicle from Boeing and the other contractors, but it will be at an agreed price. Not like the current arrangement where they build to and NASA just has to keep spending money. It's going to be a fixed price, not like the existing arrangement where the first 5 launch vehicles are not built at a fixed price, which is part of the reason why they want to then look at whether or not there'll be other launches apart from Boeing, which is the main contractor for SLS. There's a possibility that SLS won't even be used for Orion. We don't know. It really is at a bit of a grey area at this stage. And I suppose it's going to become clear over the next 18 months what's going to happen. No information further. We can speculate. Okay, so now it starts getting interesting, folks. a lot of the conversation now involved around about the lunar base, and that is basically covering like a 10-year period. There's 3 phases, and each phase was going to involve about 10.2 billion US dollars. I could argue, well, that's based on today's dollars, and we don't know whether what's going to happen with inflation, but that's what NASA's estimating it at. So they're saying $30 billion to cover everything. The first phase is going to be up to 2029, which is really going to be Artemis 5. 2029 to 2032 is where the base is going to take shape, and we're going to have a lot more things delivered there. I don't know which Artemis missions that will cover, but I think that they were looking at Artemis every 12 months or maybe 6 if they get money for it, but it has to be at least every 12 months for a landing. But there will be unmanned landings, quite a lot of them, and 2032 and beyond, which is finishing the base off, at least according to what NASA thinks it needs, right? So you can see the progression there on the right-hand side. Quite a lot of launches, and this is covering all the phases. 25 launches. I think it's 27. Then we've got 21 landings onside the surface. Some of these are manned, that's right. So I think that the maximum number of landings we've got is quite a lot of landings, as you can see. But the cargo to surface, which is the key thing in the different phases, is only like 4,000 kilos for initially, what they want to get to the surface. 60,000 kilos in phase 2, 60 tonnes, and 150,000 in total in the last phase. A lot of weight there. So you can see that what they're eventually ending up with is semi-permanent crew presence on the moon. Yeah, achieve high rate reliable lunar access, establish ground truth for moon-based landing sites, experiment and test capabilities, complete first crewed. That's just phase 1. Fairly simple in terms of what they need to achieve. Now, I found this is interesting. They have got a schematic of, and this is actually the South Pole Shackleton crater area, what they were thinking about where they might be doing landings. And it's a fairly large area there, as you can see, there's several craters. So where exactly the base ends up is your guess is as good as mine at the moment. I think that really what they're trying to do is work out where you might put a base. And there's quite a lot of landers going down into the base site. That they have earmarked an area there in the middle, and Shackleton craters on the left-hand side, I think. Sure, on the other crater that I haven't got the names on them though. You can see though that they have put a moonfall drone on the other crater there, and that's partly why it was they were going to be looking for water ice. So we'll talk about what type of assets and what they're going to do now. But this is just the first phase here, 2026, in this 3 years. So there's a lot's going to start happening. So it's going to be like every couple of months. So the main thing to note is that the CLPS is really the Commercial Lunar Payload Service contracts which they're offering. So that's what they're calling CLIPS, and that's really the funding of the payloads and things like that. That's the program that they're all in. There's going to be the human landing system, obviously. There's going to be a Viper lander, which we'll talk about what that does in a few minutes. There's going to be uncrewed lunar terrain vehicles, crewed lunar terrain vehicles, with orbital comm relays and observation satellites. And the satellites aren't there yet, but they need to put those up to be able to run proper comms. And the moonfall drones, which are used for scouting purposes, as is Viper in a minute, and I'll explain to you what they're being used for and what they do. The main things, though, that they made quite a big deal about was what they call these moon-based missions, which are really, I suppose, landing key assets for testing. That was going to be Blue Origin, Blue Moon Mark 1 lunar lander with 2 NASA payloads in September-November timeframe. Of course, that timeframe might be different now. We'll talk about that shortly. The end. Moonbase 2, Astrobotic Griffin lunar lander with the Flip rover, and that's to basically test some technologies for the lunar terrain vehicles. Astrobotics is one of the companies that have got contracts for building rovers for NASA. They've got a lander, and they also have a rover that they're going to be doing testing, and that's what they call the Moonbase 2 mission. I don't believe that's until 2027. It's either that or late 2026. Moonbase 3, which is a science mission with a Vertex payload, that's Intuitive Machines Nova C Trinity lander. It's basically for looking for some type of special surface or light spots on the surface. They don't quite understand the material behaviour, so that's just going to be doing mainly science that they're going to be sending this thing down, but it's designed to test some technologies that they might want to use for the base. So those are 3 key missions that they'd like to have landed by the end of this year, that they made a big deal about 2 weeks ago. The Moonfall drones, though, are a concept that they're going to be using for scouting purposes, and they're going to have cameras on them, and they're going to be like well, I suppose in concept you could say that some of the people had drones recently that they might have been looking at for Vivid, and also people send drones up. These are what they call lunar drones, though, that they hop around on the lunar surface. So they can land and they've got cameras, but they can also take off as well. So they hop distances by just using their thrusters. So it's going to build 4 of these initially, and that's the Moonfall. JPL's going to build them, and Firefly is going to build the orbiter that they're going to be launched from. So JPL's actually in charge of building the drones, but Firefly Aerospace is going to provide the orbiter spacecraft to go there. It is not planned, though, until 2028, at the same time that they're going to be doing the Artemis 3 land. 4 landing, I should say. What we got here? For some reason I've got... sorry, folks, I don't know why it's not moving, so I might have to do this manually, which is going to be a nuisance. Anyway, if I have to do that. Okay, so that's kind of showing you what the drones have got partly in a cross-section, very schematic. It's going to have attitude control, solar panels, avionics, main engines, and that's a simple diagram that NASA have put together to explain what the drones really do. And they really need to understand a lot about the terrain. The big problem with everything that we've seen so far is that you can see that's from a long way away. We don't know how flat everything is at all, and you don't want to be landing in an unsafe location. So you can see that launch to landing with a maximum altitude of kilometre. They're going to be like hopping these things around, so to speak. That's what they're called, Moonfall drones. And they're going to be also having cameras on them and things like that. So the next thing to note is with an asset is something called Viper. Now, this is being built by NASA as well. One stage they did cancel the mission, but it's been reactivated. I think that was partly because Jared Isaacman wants it built, and it's now going to be going up with the Blue Moon Mark 1 lander next year. It's designed basically. It's a small rover to go around and look for water, what they call water and volatiles. So it's going to land at the South Pole, and it's going to be landed at the South Pole, and its mission is going to be 100 plus days to do 30 kilometres traversal to try to work out where is the best landing sites. 3 spectrometers and 1 drill. I don't have any real pictures of it at this stage. When I have them, we can see them, but unfortunately there's nothing available. I've looked. That's all that NASA's provided. But it's one of the key projects that NASA is doing for the lunar base. They have to get a better understanding where the water ice could be in the craters, because that's the main reason for building the base in the first place. If they can't find those materials there, it's there's a good question about, well, they're doing that. So, but to make this all work, they're going to have to put up some communications and observation satellites. So they're going to have to do some launches of those in the next couple of years to improve the communications with anything that's down on the surface, but also put some cameras around that area to get better pictures. So I haven't heard anything at this stage. Obviously, the name of it's going to be called the Lunar Net for the network that they're building, but I don't know any more than that at this stage. NASA hasn't really announced the contracts for the satellites yet. So I'm assuming that there'll be announcements in the next couple of months, but that wasn't the key thing. That the assumption with that is, I think that maybe that technology is a bit more mature, so they don't need a big lead time to get those built, whereas some of the things that we'll be seeing in a few minutes need a couple of years, and they're a much bigger deal. The lunar terrain vehicles are a big thing for the Artemis 4 and 5 missions. They're a similar size to the rovers that the Apollo missions used, but the technology obviously has advanced since then, and they're going to have better capabilities. But you can see with what their deliverables are going to be, they still have to keep 150 hours in shadow because they won't be used all the time, and they want to keep reusing them. So they've got certain things that they have to fulfill, and that's what the contractors are having to meet, these standards. And when I was looking at there was 3 companies that were involved with this, and they did an evaluation in the last 18 months. So there was an announcement made at this other presentation in May of who the finalists were going to be to do the building, but there was actually 3 companies involved as well. But the third company didn't get any money, which means that they weren't quite up to standard. So, but they had astronauts evaluating the rovers in test environments over the last 18 months. So you could say, we'll talk about that in about why do they come to this conclusion? Well, they have done an evaluation. So each company is getting around about 220 million. I think one's getting 219 and 220. One's called Pegasus and the other one's called CLV1. Of course, that's because the companies that are developing them are different. Lunar Outpost is calling Intuitive Machines was the third company that was actually put a bid in for as a rover, and it wasn't successful. So Astrobotics and Lunar Outpost were the 2 companies that got rover contracts. One's got 219 for Pegasus, and they had a bigger rover apparently called Eagle, but NASA thought it was a little bit too big, and this is a cut down version of that. So interesting that was the case. Astrobotics is also they're going to be sending another rover shortly. So it's not quite clear how many rovers these contracts cover. There's going to have to be at least one prototype, but I'm not sure whether on the surface. It's not clear from the contracts. I can't find any information as to how many rovers exactly both companies are building. So I can't answer that question for you at all. I tried to get the information, but it's not available on their websites. But the Pegasus is a little bit more compact, and it probably is more likely to be used on the Artemis mission. Although, admittedly, the CLV1 mission is interesting. They have a series of different rovers, including unmanned versions, but both of these ones can be driven remotely. So they're going to have cameras on them, and they're going to also be controlled. When they land, they will be landed separately from the lander anyway. These will be landed through the Blue Moon lander, and then they'll be ready for the missions. But you can see the pictures of the two landers there. I'm going to have to. It's not. Oh, it's not. Yes, it is responding. Okay, so we've now got to phase 2, and yes, and there was a few things to talk about this. It actually gets a bit interesting at this phase because you can see at the moment they're kind of building the building blocks of the lunar base, but there's still a lot to go on with it. They've only really got the first 2 missions. They're starting to work out where they want to build it. They've obviously got to work out where water is, but now things are getting a bit more serious in phase 2. This is still estimated at 10.2, but 27 launches, 24 landings and 7 rovers. The most important rover, though, that will be delivered as part of phase 2 is the one that the JAXA Toyota rover. That's going to be a pressurised rover, whereas the ones previously are not pressurised. So this one, theoretically, when they get this, could actually have a crew of 2 to 4 astronauts in it, and it can traverse the surface. So the astronauts can live in the rover, which is a great advancement, obviously, in what you're getting so far, and quite a big deal, obviously. That's what the rover is going to look like. I haven't seen any real mock-ups at this stage, but that's the diagrams that the Toyota's developing with JAXA. So that's not going to be available till probably at least 2030, but that's what the plan is. But you can see even in phase 2, 27 launches, 24 landings, 7 rovers. Quite a lot's going on with it. 2 crewed missions per year, hopefully. Unmanned cargo landers regularly operating. The payload's going up to 60,000 kilos, and that will obviously be something like the JAXA lander rover. That's probably that big payload there. And also nuclear surface power capability. And of course they'll have moonfall drones there as well. They might launch some more moonfall drones. A bit more on the pressurised rover. Mobile habitat, yes. 10-year design life. You don't want something that's only going to be for 12 months. 15,000 kilos is not light. Can carry up to 3,000 kilos cargo. And obviously the type of slopes it can traverse has got to be something, we're getting like shallow craters and things like that. And also this 150 hours in shadow is to do with the lunar nights. This one's a little bit slower though. You can see that it's 3.5 kilometres, whereas the other one was a bit faster. That's the smaller ones. Not surprising though that's it's slower. We were showing you earlier about the fact that they're trying to demonstrate nuclear reactors on the moon. I believe this is going to be a demonstration only at this stage, not going to be the final one, but they're going to be testing it out. It's a demonstrator. I think that is planned, as I showed you earlier, for around about 2030, 31. They would like to test that on the moon to see how that goes. Phase 3, this has got a few things going for it as well. Really looking at starting to build the moon base habitat construction. Ideally now up to crew of 4. So unlike the first couple of Artemis missions are only landing 2 astronauts on the moon, they're now looking at landing 4. I can't speculate really as to how that will be handled differently, but that's what the plan is. They're also going to be landing a pressurised lunar habitat. That contract has already been negotiated with a linear space already to build this habitat. So we're going to see that. Is something that will happen in between that 2033 to 36 is what they want to deliver that to the moon. To rather than living in the landing system itself or that, they're actually going to have a habitat as well. I think that the habitat is the picture I've got on the top left-hand side there, although I've been trying to find pictures of it, but there's not much available yet at this stage, other than the fact that they're talking about it. They want to do in situ resource utilisation capability, so they're going to be sending stuff to the moon to try to test that out. And also cargo return. They want to return cargoes back to the Earth. The payload's up to 150,000 kilos, but there will be some cargo testing in phase 2 as well. Yeah, some pictures of the habitat, the infrastructure. As you can see, there's through fission surface power. So we've now got to the point where we've actually got more of a permanent nuclear service operating there for power generation. I mean, obviously there'll be generation power with solar panels where they can, but there's going to be issues about how operational they're going to be, given the restrictions sometimes with sunlight there. So, it depends where it all's situated. As you can see, they've also got something like a power. So this is a NASA diagram, but we don't know exactly whether it's going to look all like this, but that's what they're showing. I was talking about earlier about the habitats, but the thing to note with the habitats is that they're going to have airlocks for astronauts to get in and out, and they're going to have an ECLS, which is their life support system, closed loop system. It's something similar to what they've got on the ISS, I suppose. But the difference with that is that it's going to be on the surface itself in a large module. At the moment, Linear Space seems to be the ones that are developing those. They have a lot of experience with modules. They've got modules on the ISS at the moment. So they would be, and also they were building stuff for the Axiom space as well. So if anybody's going to build a habitat for NASA, they're certainly the ones to do it. Looking at logistics services, obviously logistics services really involves just the delivery of cargo to the moon. There will obviously be providers for that, and that'll be a contract that covers that. Obviously, Blue Origin's one of those companies that could do it, but of course SpaceX could be involved with delivering cargoes as well. That'll be a contract that NASA will send. It's not clear exactly what exactly they're going to be doing with that, but they've come up with ideas on how much material needs to be sent there. So the thing to note about this lunar base is I don't think I've ever seen a proposal before from NASA about how you build a base. So the significance of this is that now we are actually seeing NASA talking about all the different components to a base and what you need to do to get it to work. And that's what they've outlined here. Now, this is just talking about the ISRU. Basically it's processing lunar commodities to get materials off that. Some of those things will be recoverables from the regolith, which will be oxygen, water, and maybe rare earth elements. So if they want to do things with the moon itself to try to live off the land, so to speak, they've got to try to work out whether they can get this to work on the moon. And that's going to be something that will be important to try to get operational in the third phase. That's what the plan is of setting this all up there, is to get the base. But as you can see with the regolith, they want to actually try and see if they can do 3D printing to design things as well, sustainable materials. And as some people have said, they might also want to use the regolith to cover the habitation modules too. I know people have said that because of radiation. So not being talked about by NASA, but I know people have discussed it. So it's something that's in place. Cargo return, yes. They want to do a demo in phase 2 earlier, but they want to try and, in phase 3, mass up to 500 kilos at a time. And when they say science returns, they'll probably be sending rocks back. That's the important thing about it, and maybe things they want to replace or test. Something that really hasn't happened that NASA's done. I know the Russians have resent materials back from the moon and cargo return. They've certainly done that. And that's all, folks. So we'll turn it over to questions. Just give me a minute to get my voice back. Yeah, so sorry, folks. I've got to try to work through all this. Okay, yep. Okay, so I'm just going through the questions. I'll try and go through those and then you can ask other ones. Moving some of the racks. Yes. Yeah, I would say that if you're looking at, going through the question that Scott's asked about some of the racks in the interior from the ISS to its successor, you've got to look at the modules that were attached to the ISS. There was 3 different modules. There's a US module, there's a European module, and there's a Japanese module. I think the Americans are obviously interested in getting the racks out of the US module. Okay. It's not clear to me, though, whether who's going to be responsible for getting that, because how it works was, I believe it's the racks in the US module are only American. The US government owns the racks, whereas in the other modules, the Columbus module and the Jackson module, I can't remember the name of the Jackson module, but they were, some of them were, there may have been some US based racks in them, but also there were European and Japanese racks in there as well. So the question really is, what are you going to move? I would think that the Americans will move their racks, but I'm not sure about other people's racks. Also, some of the racks that are used normally are not necessarily for equipment or as an experiments. They're sometimes used like a space for other types of things, or things that are used on the station. So they would be going to be looking at stuff that's scientific based, and that means that some racks may be not needed to be moved. Yeah, the idea also with the racks, Scott, is that theoretically they can be removed. They're not welded. So they're welded. The rack itself is built as a rack, and it's a single rack, but they can actually be slid. They're like on rails, and they can be slid out, which means that theoretically, but they have got electrical and liquid connections, so you would actually have to disconnect them, right? But you can get them out, apparently, providing you've got enough room to move it into a module. But the modules in the ISS are theoretically large enough to get the racks moved through, because this has already happened when they were delivered from the shuttle. So that already has happened once before. So in fact, I think you can go back and look at pictures of them installing the racks. So I was interested when I heard this, was something I'd never really thought of, but apparently NASA has come to the conclusion that a lot of the racks that are on the station they don't really want to lose, because I suppose it would cost a lot of money to send them up again. So they'd like to reuse them. So that's probably the best I can do. Are you happy with the answer, or you think I can't? But it's a good question. I would say, though, that it was going to be the US racks, so I would not scope in the European and Japanese racks yet. But certainly it's not touching anything in the Russian component, though. There's no racks that the Russians have got that the Americans would be touching. Okay? So make it quite clear that where we're looking at is only in those 3 modules, is where anything's coming from. Okay? Hopefully you're happy with the answer on that, because I can't say any more. Candidate isotopes for SR1 freedom. No, I've got no idea, Julian. I think at this stage it is very much early days, and we'll have to look into that as to what the SR1's going to do. You can see the timelines we're talking about. It was something apparently that Jared Isaacman was interested in, particularly as a visionary type, you know, mission, Pathfinder type mission, that they should try to look at the technology. So I think it's more the case of they worked it out in February this year, and now they've got to work out the detail to try to meet an end date of 2028. So you could go back and look at what isotopes they're using in the current rovers, I suppose, and see how big they are. If you want to go back and do some study yourself now, you can go back and look at what is in those two rovers that are currently on the surface of Mars and see whether or not they would be candidate isotopes. However, I believe that this is going to be using it's going to need a lot more electricity, so it's obviously going to be a bigger generator, RTG, so to speak. Okay, so Jeremy's answer, yeah, that's probably right. And it'll only be between 5 to 20%. And if you think you're going to be getting 60%, you're not using it for peaceful purposes. Unlike a certain country that we can think of at the moment that claimed that they didn't understand what 60% meant. Okay, so nuclear reactors at the moment are usually between 5 to 20%, depending on what type of reactor it is. I believe some of the new ones only use 5. They're just more efficient. That's fine. Yeah. Agreements. Just remember though, they've already sent the reactors to Mars already. So I would have thought already that there must be something in place about using, although they're using it on another planet, not so much in the Earth's atmosphere. So I suppose, or rather in space. Good point. Probably there is something in place, but interestingly enough, remember, NASA doesn't necessarily adhere to some of those international agreements. So you've got to remember that too, that some of those agreements that I'm talking about, all of them, NASA's not signed them. So no, I don't know about the ban of nuclear energy in space. I'm not aware of that though, because otherwise you probably wouldn't be able to launch anything. Blah, blah, blah. Yes, that's right. Jeremy's a space policy person. So you're on top of everything, Jeremy. I don't have to answer some of those things. That's good. Yeah, LunarNet standard. Yeah, interesting about that. I understand Motorola and Nokia are involved with this LunarNet standard. Interestingly enough, Nokia doesn't really make phones, but I believe seeing something a couple of years ago that there's been some people working on this for a little while on the standards involved from a commercial perspective. So I think that it's been worked on for 2 or 3 years already, because I recall somebody talking about this at the New Horizons Summit that Greg Hunter was running. The 2024 one, somebody was talking about even the LunarNet standard that NASA's working on for Artemis. So I think it's been under development for a few years already. And I think that's also partly why we haven't seen as much in terms of making announcements about the satellites yet, because I believe that there's a couple of players already that could do it. It's just that they don't need them yet. So they won't take them too long to get them up there. Drones on the moon, yeah. How will they work? They're just going to be really a bit like a hopper, Lou. So you can see what they were showing with these. I think the word drone is a little bit. It obviously hasn't got propellers like the drones that we've got on Earth, but they're using the term moonfall drones. I think it's a bit of a cute marketing word they're using, but the concept of a drone on Earth is that they hop around a bit and they're used for aerial photography. So I think really what NASA's trying to do is to have these things hop around on the moon, and they're going to be taking photographs and they're going to be looking at sites, and they and I think I showed a cross section earlier. We can go back to that maybe if I got some time to. Yeah. Let's see. Getting there. Here we go. All right. Okay, so you can see that that's just a cross section of it, and I kept that diagram as well because NASA there's some other pictures that they took in other documentation they had on it, which was on their website, but in the presentation they showed that, and it really just shows you what it consists of. They're very basic things, and they've got solar panels, and they've got some little engines on them with batteries and cameras. So they just hop around. There's going to be 4 of them, and JPL's going to build them. So you could argue, why isn't there a lot of information? I'm sorry, but JPL hasn't published any pictures. They've published a picture of it, but they haven't shown us the real hardware because they don't believe they're finished yet. So it's an unfortunate problem with some of this. It was a presentation of which some of it is not there yet. But anyway, that's what it looks like. And the idea is that they're going to be scouting. So they're trying to find good locations to land, and they're going to be looking for water. That's what... Yeah, I know. Abusing the English language. Well, I mean, that's right. It's a terminology issue, and the business about the helicopters that they were going to be doing on SR1 Freedom, they were going to call them Starfall. That was a bit. Sorry, the Skyfall, I should say. That was a James Bond movie, wasn't it? So they were just being cute with the marketing term on that, and they had 3 helicopters that they were going to launch off that thing when it comes into land in the Martian atmosphere. So, it's I suppose you can call it that. I mean, it's like, why does Elon Musk call Starship? It's yeah. Any talk of track, road construction, or material waste recycling, repurposing? No, I believe if we're talking about with the ECLSS business about recycled, that's kind of like going to be in the habitat. So you're not going to have an outside outhouse if that's what you're talking about, or something like this waste recycling. I don't know if you're talking about human waste or lunar waste. It looked to me like they had some pictures of it. Let me see here what the base would look like with phase 3. Yeah. To me, it's not really. A lot of everything seems to be on the surface, and whether they're doing anything else about rearranging it. Yeah. I really think that's a bit too early at this stage. If you ask me, this was a very good attempt at NASA to actually quantify what they're intending to do. Because if you think about all the times that NASA said they had never committed to building a lunar base, even though we have been talking about this for years, and this only really happened instead of the Gateway, and it made more sense that you build a lunar base rather than building a space station around the moon. I know that they say that you could do certain things around looking at the moon, but it doesn't really make any sense in going back to the moon and not actually going on the moon and making a permanent base there. But it became a little bit more urgent given the fact that the Chinese were thinking about landing on the moon as well, and they may decide to set up a base as well. So the Americans wanted to make sure that they have a base. And that's really what this is a statement of. As to who's going to get there first, well, your guess is as good as mine at this stage. Very hard to say where the Chinese are really up to yet. They still have to do more testing, and the Chinese are very guarded with making announcements. But the problem we'll have with China is that they'll probably make an announcement like a month out when they're going, and you won't get any telegraphing like what was happening with America, where it's very obvious as to what they're doing, and they've telegraphed it. Whereas the Chinese, you'll just surmise based on what's going on, and then they'll announce that they're going. So, and that's what they have done very much with things. Yes, okay, put in the rovers, but the US would need to fire up. Okay, yeah. There's quite a few rovers that people are talking about landing on. I've seen some interesting astrobotics that have got one of the rover designs there, that they've actually also got a rover that follows around the astronauts that has just got cargo in it, and it's not actually something that the astronauts sit in at all, but they can ride on the back of it, so to speak. But I've seen one of the other designs on the website that NASA tested, so I can't see exactly. But what I've shown there is basically what they've selected. I wouldn't be surprised that they might also have some other lunar terrain vehicles that might get contracts for later. This is very basic, what you're seeing, and you have to remember that last year this was not on the agenda for NASA at all. So the fact that they've got this far in terms of coming up with a project in terms of what their plan is, I think is admirable. But where we really have doubts from my perspective is the time frame. Yeah, they're going to stick to it. But at least they have a plan, and the problem with anything is if you don't have a plan, you can't even work towards it. So they'd to be lauded for at least coming up with a plan, I think, and that's the great thing about it. Okay, I'm going to shut up now at this point, and you can say something. Sorry, because I've run out of voice.
Wayne, I had a question there about radiation, whether that's getting much attention.
Look, I understand what your question is. Is the radio? Yeah, okay. I must have missed that, and I do know that that's one thing you're worried about. So where is your? Okay, getting much published attention. No, I could say maybe not, and that was why I was interested when they were talking about the habitat that was going to be sitting on the surface rather than buried. I understand that people have talked about this, but longer term we might have to live in lava tubes or something else instead of on the surface because of the radiation, or rather, not so much the standard radiation, but if you have a, coronal mass ejection, CME, that's what you got to worry about. Yeah, NASA really hasn't addressed that at this stage in anything I've seen. No. I would think that they need to, and I'll be interested to see with this habitat as to what type of radiation shielding it's got.
Yeah, could be in
right.
there.
I mean, it could be in there already, and maybe we're worrying about it. But I understand why you're saying it. Yes.
Yeah.
Because certainly it's something that I've thought of and you thought of, and that's why sometimes with some of these things the public's not really thinking about things like that, but maybe people like us have got a bit better worried about understanding how complicated some of this is, that they're not. I mean, that's why, as an aside, I keep laughing when they start talking about data centers in space, because I know that Tony and Eva have got their own opinions about radiation and how big a problem it is to try to get chips up in the Earth's atmosphere, up around in Earth orbit, and then you got to worry about the same type of problems on the moon. It's an issue that they have to really deal with properly. I know that the moon really hasn't got exactly the same issue with the some of the problems that Earth's got with constant issues with that. But yeah, I have not heard anything about it though. But you're right;
Okay.
it's something that needs to be considered. Um, yeah, it's when I did the research on this, I really tried to find out as much as I could. But where's the food coming from, Ian? Yeah, good question. um, I I don't think at this. I think at this stage they're planning on bringing it in. They need a habitat module where they can grow things. There's no indication that that's planned yet, but I think in phase 3 it might be possible. But I would think that at the moment everything will go to the moon and be shipped in until phase 3, and that's when they're going to be trying to set up a permanent base. Um, but as to how, and in terms of the growing it, yes, there's people working on growing things in space now, probably more so in Earth orbit, but certainly on other places. But it's not something that NASA's talking about actively yet. But if you've got to look at it from a fair perspective, we are looking at it from a very high level. If you're looking at the number of, say, launches and landings, just the sheer number of launches and landings is frightening. We'll just go back to that overall slide, and I kind of didn't really cover that properly. All these 25, 27 and 29, those are in the different phases. So that means in phase 1, I forgot about the symbols, and it is a little bit confusing sometimes with the way it's been drawn up. But in the first phase up to 2029, there's supposed to be 25 launches and 21 landings. Obviously, that means that there's four missions where there'll be satellites sent up and they'll be in orbit, right?
Wow.
And that's the difference between, say, with phase 2, we've got 27 and 24. So that means that there's also going to be 3 satellites going around the moon, and they will not land, but they will go around the moon instead, right? So that's really the difference between the number of launches and the landings as to why the numbers are different. It's to do with the satellite constellation that they have to build. Okay, so that's really explaining why phase 1 has got 25 and then it's only got 21, because there's going to be four launches just used for satellite constellation, which makes a lot of sense. They do need to set up a constellation around the moon. There isn't anything there now, but there's no contract awarded for it. What I have done so far is explain to you what has been awarded, and what they mainly seem to have focused on is the traverse vehicles and the spacesuits. And those are the ones which are going to be difficult to, they're the most difficult payloads, I suppose, to build, and that's why they've given them so much lead time to do. And the other thing, obviously, that won the contract was the Blue Moon lander. The thing that we obviously hadn't talked about, in the elephant in the room, is what happened with New Glenn a couple of weeks ago. For that reason, we don't really know exactly what is going to launch Blue Moon Mark 1 yet. People have talked about, is it going to be New Glenn? Well, if you're going to have to wait for New Glenn, the earliest that New Glenn can be ready is December 2026. They have looked at what has happened to the launch pad after it all was badly damaged a couple of weeks ago, and say that they might have it ready in 6 months, but I think that's really optimistic. There's been discussions whether or not SpaceX can launch it. Maybe. In fact, I saw an interesting presentation today from Scott Manley about what was, and I haven't unfortunately included that, as to what might be an Artemis 3. I was a little bit sceptical about some of the things in it, and part of the reason why I tend to not put some YouTube videos in deliberately is the amount of AI that's being used with these and stuff that's what I call speculative. You folks weren't aware, 20% of YouTube is now AI generated. You have to be extremely careful about what is really useful information versus garbage, and it's all designed to get views because they want to make revenue out of the advertising, right? So the problem is that with the amount of advertising that's being required. There's so much stuff, but in fact, YouTube is now making it compulsory for declarations. If you don't declare it, you can be removed. And you are now seeing stuff that's been classified as AI generated. So that's something you may not have been aware of, but this has only happened in the last 2 weeks that this has all changed, even on YouTube, with because there's too much AI generated stuff. I saw something that estimated that there's 20% of YouTube now is AI generated, which is really a problem because you've got to understand everything with context. And for that reason, why with the space stuff in particular, there's only a couple of content creators I would bother to look at consistently because I know that they're serious journalists and they don't want to tell silly make up things because it's their reputation they're concerned about. Whereas some of these people are a bit too anonymous for my liking. So going back to the blue moon, they were going to be using a slightly different variant of the Mark One, even because the problem that NASA's got is that they are trying to test out stuff for Artemis 4, and Blue Moon Mark 2 is not really even ready and wasn't even supposed to be ready until 2030. And they want to land it 2 years earlier. So they were thinking about a 1.5 variant of it, which has got a different capsule and the descent stage is going to be the same as the existing one, but a modified capsule, more like the one that they were going to have in version 2. So watch this space, it's all changing. And the other theory for Artemis 3 was that SpaceX is not going to have really a very advanced Starship available. It was just going to put a docking port on a Starship and have Artemis 3 dock with it. Now, because they want to at least test that much out. So we don't know what Artemis 3 is exactly going to do yet. It's what NASA wants to do, but yeah, anyway. Okay, so dynamics works on the moon. Yeah, okay. That's what Julian's answer is. I don't know. Gravity perturbations. No, there's currently a couple of spots to do with in the Earth's orbit where there's some very serious interference with chips. Tony, are you still there?
Wayne,
You understand all this. You were talking about the problems with the ISS going around the orbit at the moment, where it gets every is it every it's not continuous in one particular. Isn't it over the Atlantic or something? There's
hang on, just slow down. There's two things. There's bursts of radiation from the sun from time
yeah,
to time.
that's right. That's right.
But also there's also a region of low Earth orbit space over the South Atlantic called the South Atlantic anomaly.
Yeah, that's the anomaly. That's right.
Region of enhanced radiation. It's a long story. When
Yep.
they pass through that, they have to retreat to the lifeboats. All of the astronauts have to retreat to the lifeboats. And when they go through, it only takes a minute or two. They have to go and reboot all the computers. And there's about 180 of them, right? So
Yes, and that's to do with the ISS orbit to some degree, and it doesn't go over the anomaly all the time. It goes
it
around
doesn't. No,
progressively.
wait, hold on. It only happens once every now and then. Okay,
Yes,
it's not
yes,
common.
yes.
So that's a low Earth orbit thing. The
Yep,
moon is the problem is that you're outside the Van Allen belts,
that's right.
and you're subject to constant radiation, and so you do have to take a lot of time and trouble to
Mm,
protect, firstly the astronauts, but also yes the
mm.
equipment. And to answer Alan's other question, radiation is a problem, yes, for data centers, but the biggest problem, and no one's spoken about this yet, is cooling them.
Yes, that's
So
exactly
you only
right.
have one way of cool. You can generate all the energy you want, but then you've got to cool them again. It becomes heat when they're finished with it. And dumping heat, that much heat into space without air is a very, very big undertaking. And it's a
Yes,
very big thing.
but also with chips too. As you know, with how chip generations tend to work, is that sometimes they only have a 3 year life,
Well, no, they have a long life, but they're in a high stress environment.
Oh, no, I was more thinking about the fact that if you know, like at the moment with chips, sometimes the architecture that you would be using for, say, these AI data models, that
Come
you're,
obsolescent quickly. That's what you mean.
yeah, the obsolescence is a problem because at the moment on Earth it's easy. All you do is go and swap the chips out in a data center that you can get access to. If it's in an Earth's orbit, it ain't going to be swapped out like that. You can't be.
That's right. Yeah, but no one's spoken about the cooling yet, and it's
Yeah,
important.
I know, and it's there was a few things that we already know because that's what happened with the Kawaba satellite too. You got a radiation spike on the
Yeah, well,
on.
it hits some radiation either in the South Atlantic anomaly or
Mm,
the it was actually Inspire too,
go
um,
Inspire, sorry. Yep.
or a very big burst. There was a very big burst after about 100 days of the
Yeah.
mission, and it had a pretty profound effect on the orbit, but it damaged a lot of the spacecraft as well.
Yeah, so the idea of the ideal world that people say that you can just send these things up. Normally, even on the ISS, they never send up the latest model computer chips. I mean, I know with mobile phones it's not such a big deal. They are taking the newer phones up, but the problems with the laptops and things like that, they always have a tendency of using much older ones
Yeah,
because they know that,
they're usually a generation behind. Yeah.
yeah, that they've tested them from a radiation perspective, so they know that they're not having problems. So they're concerned about things like that. So, yeah, on the moon, Alan, yeah, there is some things we've got to be careful about. So, yeah, it's not a silly question what you've asked. Yeah. At the moment, I'm hoping that we'll get better advice from NASA. But I think the problem with the two media presentations we've had so far is that there's so much stuff literally being done from a PR perspective. It is really very much in that phase at the moment, and that NASA thinks it's costed it out. It now understands what it thinks it needs for a lunar base, but I think there's a lot of detail that's still going to be added. So I hope you enjoyed tonight, but it's something that 12 months ago I wouldn't have been talking about because there was no discussion about building a lunar base, and not seriously whether they've actually worked out what they think is the number of launches and landings for to build one, which I found was great that they've actually done it. But we haven't had to talk about it until now. Okay.